Lecture D04, facade components. This lecture goes about shading devices. Functions of the content of this lecture is functions of facade, influences of solar shading systems, logical solar shading systems, their position and their mechanism, and some samples of shading systems. The typical functionality of a facade which we have to tackle, which we have to deal with in our design is sun protection, that's the shading, ventilation, we need to have open windows, heating and cooling could be part of this, and the light, artificial and natural light, is part of the design aspects of a facade. The influence of a shading system, these are the aspects which we need to tackle or need to identify as questions when we discuss shading systems. The daylight level, how much daylight do I get at the inside of my building? The view to the outside, an important aspect as well for the function, for the user of a building. The reduction of solar gains, that's what shading is about, reducing the impact of sun. This obviously modifies the thermal exchange, and this obviously also influences the consumption energy or energy in use of the building in the means of light. If we shade, we may need artificial light. In the means of heating, if we shade, we may need additional heating, so that is a contradiction. Or in cooling, so if we do not shade, we may need to cool our building. So obviously shading, the solar gain and the shading does influence the entire energy package of the building at all. We need to think about position and mechanisms. Position of shading is super important. Why is that? Because we have this solar impact aspects, reflection, absorption, and radiation. Reflection means sun hits the glass and is directly reflected, which happens at a certain angle or with a certain coating of the glass. Absorption means the glass absorbs the entire energy of the sunlight, which then ends in a transmission reduction in the means of some energy is reflected, some energy penetrates our facade, and some energy actually stays in the gas sheet as well. This energy in the glass will develop a heat gain at the inside, which is the radiation in this picture defined as transformation. And then we obviously also can identify or think about solutions to select the solar gain, reflect some parts of the light, and have some parts of the light penetrating our system. This whole thing is defined in the so-called G value. The G value defines in a percentage number the energy transmission through the glass, by the glass, into the building as a set. And when we think about different types of shading systems, when we look at this one, without protection, so no sun protection, the G value is 100% of the energy is impacting the glass. If we have a horizontal shading device, a brise soleil, we will see later, we may have a G value of 0.5 to 0.7, so 70%. If you have an interior sun protection device, so at the inside of the glass, the energy is already penetrating our glass, heating up the inner air, and that leads to, say, very limited performance of this inner protection with 0.7. If we have an sun protection somewhere in the cavity, in an IGU, insulated glass unit, small louvers being integrated, Venetian blinds being integrated there, this may end up with an 0.7 to 0.6, so 60% of energy impact. And the best way to create shading is an exterior shading, which means it's the Venetian blinds maybe at the outside of the system, which ends with a 25%, 0.25, 25% of efficiency. So only 25% of the energy is then getting through this whole system to the inside of our building. We have to think about the position and the type, the mechanism and the position of our shadings, positioned as just defined mechanisms, either fixed or movable, either external, either internal, or either in between. And then there's some other types which are interesting to see. So fixed, first one, fixed, a horizontal blind, which could be fixed, which could be also brought into components, smaller components. Positive part of the fixed movable one, as it is defined here, they may tilt and by being able to tilt, they allow heated up air to cross this area. And then we have this one, this fixed one, which is a horizontal blind, which allows to block the lower part, but also allows to maybe have a reflection area at the top part to get sunlight into our room, into our building, if we want this to happen. Fixed movable, the Venetian blind at the outside could be brought in position. We see some samples later. Movable Venetian blinds within the glass cavity, the insulated glass unit, and another one which is fixed, which is a brise soleil-like shading system, which is entirely fixed and brought in position, depending depending to the position on Earth, orientation of the building, and by that the sun to reach the building. Missing words in this lecture. Solar shading types, which we can identify: the sunscreen, the inner sunscreen, as I said, the one with a very limited efficiency. So we see an inner sunscreen here. Actually, sun is hitting our glass, penetrating our glass, heating up the inside air, and then it's not a sunscreen. De facto, it's actually a sun blind. So it blocks glare, but it doesn't really block the energy impact. Next one, brise soleil, horizontal component on above our window, which blocks a certain level of light. Does not work in all directions. South is maybe good because the sun is having a certain angle, but if it's east-west, it may end up be less efficient as a system. We can see these brise soleils in this sample. It's building of the 1970s from Oskar Niemeyer, and the big picture which we see is the one side, which is south-oriented, and the smaller picture is the other side, which is the north-oriented, on the northern hemisphere thinking, which by then shows north there's no sun protection, south there's a maximum sun protection. So they actually do a brise soleil horizontal, and they actually move it a bit outside to secure that there's no sun penetrating the glass as expected. We can have fixed louvers, horizontal and vertical, as set up. These fixed louvers are maybe fixed in position, are maybe fixed in angle, but they also may be tiltable, so they may also change their position depending on the sun angle and direction to our building. Then we have green. A sample from Germany. You can imagine the green does block off a lot of sun. It's an 0.5 G value, which we may argue, but you have to take care that this green stays in position also in winter time, and that it could be maintained well. That's an issue which is always a difficult one with green system. Then roller blinds, outside roller blinds. It's an 25% efficiency if the roller blind is brought in position. The difficulty we normally have with roller blinds is wind impact and stability of these blinds next to Venetian blinds. Venetian blinds are aluminium profiles which are brought in position, could be lowered and brought in position where we want them, maybe even being tilted to a certain level as set, and then horizontal sliding blinds. This is a sample of horizontal sliding or the fixed blinds, which could not be moved horizontal, but you can imagine how horizontal blinds could be brought in position. I'm talking about these parts, blinds brought in position. And then last slides of this lecture, we need to think about how can we secure that we shade our building, but still allow that the natural light finds its way into our system, and we need to try to find a way maximum deep in our building. So it either would be possible with an opaque glass with a scattering system, some reflection system which would allow the light to be diffused into the room. The other one, a light shield, a radiation shield, a reflection to the inside. So we actually can block this lower part, reduce the energy impact in here, but still have some light, which may be with an even second reflector being brought very deep into the room, which is an opportunity. Or light tubes, actually profiles which allow the light to come to our shelf, then being reflected maximum deep, and then maybe left into the room at the inner part of the building. They do work, but the efficiency is kind of limited. Now, yeah, opportunities to get light moved into the building within the facade. Some literature about this package, and the final slide, who was involved and where all this comes from.